Hey folks, it's Rick. I haven't made one of these videos for a long time, but I've got a brand new app that I want to tell you about, and that app is called MB Tile Maker Viewer, as you can see here in the About box. MB Tile Maker Viewer allows you to make tiled maps of just about any map that you can import as a GIF, PNG, or TIFF file. And it allows you to mosaic maps and output MB tiles files, but also output TIFFs and JPEGs and so on in spherical Mercator projection. So let's get started. Here's the basic screen for MB Tile Maker Viewer. It has three panels: the georeference panel, the warped image panel, and the MB Tiles panel. And the area down here in the georeference panel is where you enter control points and so on. So let's actually do a map. We're going to use the Bob Compton map of the Raft River Mountains, and I just did a drag and drop to drop that file right on the window. Alternatively, you can go to File, Open, and open it that way. But here you can see this nice scan downloaded from the USGS of the Compton's map of the Raft River Mountains. Now, the first thing to know is that you move the map around simply by clicking and dragging. There are no scroll bars or anything. You just simply click and drag. To zoom in or out, you use the scroll wheel on your mouse, or you can use a contextual menu to set the zoom level between 10% and 400% zoom. Now, let's go take a look down here at the lower left corner, because before we can georeference this map, we need to know what the datum is. You can see that the base of the map is from USGS 1 to 62,500 scale topographic map from 1959, and that undoubtedly means that the datum for the map is NAD 27 CONUS. CONUS stands for Continental US. So we're going to set the datum there. It's important to set the datum because latitude and longitude points in different datums, the same latitude and longitude in different datums, are not in the same place. In northwest Utah here, there's actually about 60 meters of difference between NAD 27 and NAD 83, which is the most modern one. Okay, let's get started geocoding now that we've set the datum. You can set the datum anytime before you actually do the warping. So to set control points, we go to georeference. You need a minimum of 3 control points. So you first set point 1, point 2, and point 3, and then you can add as many additional ones as you want. I prefer to use the menu command 1 or control 1. Click there, and then I come down here and use the longitude and latitude have to be in decimal degrees, but I'll show you in a minute how you can get around that. But for this first point here, I'm simply going to type minus 113.5 and 42. And you finished entering the control point when neither one of these boxes is selected. All right, let's go to the next corner of the map over to the right here. And we'll do this again, except I'll use command 2 or set point 2 to do that. And I set that point right there. And I type minus 113.25 and 42. And sometimes with a big map, it's easier to zoom out and then zoom in again on the place you want to do it. Now for this one, I'm going to show you a different way of doing it. This is control point 3, command 3 works. And so I click here, and now I'm going to enter them as in degrees, minutes, and seconds. So this one is do 113 space 15 and then type a W. And when I tab out of that space, you'll see it has converted the longitude correctly to its decimal equivalent. So you can enter control points in either decimal degrees or degrees, minutes, and second. To emphasize that point, we'll do 41 space 45 and north. Can be either uppercase or lowercase. You don't have to have a space after the 45, or you can put one in if you want. When I tab out of there, it correctly translates it. Now, 3 points is the minimum number that you need for georeferencing, but we're actually going to put in a fourth point here at this corner of the map. And to add a fourth point, this menu, add another point, is now available, Command A, and you can add as many additional points as you want by choosing Command A. And the program will do a least squares best fit to give you the best possible fit. You seldom need more than 4 to 6 control points in a map. All right, and I'm going back to decimal degrees here, minus 113.5 and 41.75 for the latitude. Once we have our map, we can now warp the map. And to do that, we go up to Georeference, Warp to Spherical Mercator. We're warping to Spherical Mercator because MB tiles, and in fact all tiled maps on mobile devices, use a spherical Mercator projection where we pretend that the Earth is spherical, which really vastly speeds up the calculations quite a bit. All right, it does take a little while to do a warp. A 10,000 by 10,000 pixel map has 100 million pixels in it, and each one of those pixels has to be its new position in the warped map has to be calculated separately. So here it is. This is what you would see on Windows and Linux. On the Mac version of the program, it actually puts the map on top of an Apple Maps satellite view, so you can check the georeferencing. So for example, if I come down here, you see I have a network of roads. I can vary the transparency, and I see that, in fact, those roads pretty well overlie. Not perfectly, because it's a scan of a paper map, but pretty close to what I wanted. So now, if I'm just interested in this map, all I need to do is go save as MB tiles. But what I'm going to do now is show you some other aspects of it. I'm going to go back to the georeference, and now I'm going to drag an adjacent geologic map. This geologic map is Michael Wells's Kelton Pass geological map. And now the program asks me, do I want to merge this new map with the existing warp map to make a mosaic? And the answer is yes in this case. This map is a much more modern map. Because it's cropped from a larger topographic map, the boundaries of the map do not actually have known latitude and longitude, except we know the longitude of this boundary here. So I'm going to show you how in the Mac version you can use the built-in visual referencer, georeferencer. And later in another screencast, I'll show you how you can do a similar thing using the web version of Google Earth to do the same thing. So we come up here to map, to georeference, and I choose visual georeferencer. And I now have a map of all of North America. Raft Rivers are in northwestern Utah, of course. And I just click and drag and zoom in on this part. And the Kelton Pass quadrangle covers this area. Now what I'm going to do is to try to find a series of road intersections that on the map and in the topo map to try and choose georeferencing points. We have a road which comes out from the end, which is probably this road right here. And we see this intersection here is this intersection. So I now go set point 1, choose that point on the map, and that point on the georeferencer, and it's automatically entered the latitude and longitude. You can't choose the datum here because the datum of the satellite image is always WGS 84. So now we can zoom back out. Let's go to the eastern Raft Rivers and find another one. Yeah, Cedar Springs here is a good one. That should be somewhere around in here. And there's Cedar Springs right here. And this intersection here is that. So we're going to click 2 and 2. And finally, let's do a third one down here. Here's the road that comes out of 10 Mile Canyon coming out right here. And I'll do this. You do have to be careful because, of course, dirt roads can change their position over time. We see this nice bend with an intersection there. Let's see if we can find it here, and it's right here. So we can have our third point, which is right there and right there. Um, that's all I need to do, but I can put in another point just to be safe. There's a big bend in the road at the head of 10 Mile Canyon, right up in this area here, which I think I can find on the map as well. This bend right here. And let's go find that. And there it is right there. So let's put in one more point right there and right there. And we're all set. Now we can georeference, or now we can warp this map, choose warp to spherical Mercator, and we have to wait, as you can see, a few seconds. But remember, the uh, program is doing tens to hundreds of millions of calculations while we sit here, and it's a lot easier than doing it by hand. And once it gets to the end, it takes us to the warped image pane. And now we see the old map, which we'd already georeferenced, and the new map um, laid right on top of it. Okay. Now, there are a couple of things that we want to do here. First of all, we don't like these borders. So I'm going to crop this image, which is on top, so that this border is nice and flush with the adjoining Raft River map. And I do that by going to Map, first drag to select. So I'm going to position this here. As you can see, it has handles, so I can reposition it once I'm done. If I zoom in now to this area and do some fine tuning to get that right on the border, drag up here, looks good. And I'm actually going to drag this down a little bit so we capture the scale, and we're going to keep Michael Wells's name in there, so he gets credit for this map. And when I do, now I come up here and go crop selected, and the two maps are now nice and neatly joined together into one map. The big map, we really don't need all of this. And so what I'm going to do now for this, for Bob Compton's original map is crop that to, and I can go to the map, drag to select, or Command or Control G, and we'll do this. And I'm actually just going to go down to the Park Valley Road because we don't need the rest of this. And go Command K, which does the crop. And there we go. In this view, we can, of course, vary the transparency to check the fit and so on. But I'm going to show you some other tricks. First of all, this is a great map, but the colors are a little washed out. So I can actually do some image processing on the map before I save it to make it pop a little bit more. So I can select the map. Note when a map is selected, it has green handles at the corner. I can select the map and then choose adjust warped map colors. And I get this dialog box here. And I'm going to change the black point, which will make the overall the map darker and the colors stand out a little more. Uh, and I'll give it a little more contrast just to make it, again, stand out more. Because this was started as a digital map, I don't need to do any sharpening, although I could if I wanted to. Actually, let's do just a little bit of sharpening as well. Now I want to save the map, and I can do that by saving an MB-Tiles file, or I can save the warped image as a JPEG, PNG, or TIFF file. And I want to save the whole mosaic rather than just the Raft River map, which is the currently one selected. So I'll go Save Mosaic. I give it a name, save it. There's already an older one there, but I'm going to replace it. And now it sits here. You notice that this is spinning. That's because the map, because I have the GDAL geospatial libraries installed on my computer, it's actually finding the correct GDAL commands to save this output TIFF as a real GeoTIFF with embedded georeferencing information that other GIS programs and so on can use. And when it's done, it tells me that it's saved it. Even if I don't use GDAL, it will save it with what's called a world file, a little sidecar file that gives georeferencing information. All right, now we want to go to save the MB-Tiles because we want to use it, say, in my GMDE Lite program or the many other mobile apps which can import MB-Tiles files. So I go Save MB-Tiles, and let's call this Raft River. And I'm going to save it to my desktop. I click the Save button. If I move this over here, I click the Save button, and now you have to set the MB-Tiles parameters. It is set with a minimum zoom of 11 and the maximum zoom being the largest zoom that the program can produce for you. In this case, zoom 18, which is 0.6 meters per pixel. That would create 132,000 individual tiles. And that's probably more than we need for this project, since these are both started out as 1 to 24,000 maps. We'll just go to 16, which is a much more tractable thing. Now, the other thing you have to decide is whether to use the tiles are going to be in PNG or JPEG format. PNG has the advantage of being transparent. So for example, if I save this as PNG, these areas down here or above the Kelton Pass quadrangle would be transparent, and whatever you're using as a base map would show right through. It has the disadvantage that it's much larger in size than JPEG. And JPEG, we can adjust the compression level to say 30 or 40. And we're all set now. So I hit OK, and the program is saving those 10,000 files or so. And when it's done, it shows you the map as it's been produced, and so on. You may remember we actually saved the scale on the Kelton Pass quadrangle. So let's go down to it now. And although you can't do very much in this program, one of the things you can do is measure distance and bearing in any one of the screens once a image has been georeferenced. And when I do that, then I can click and drag, let's see, along the scale bar here, just to check to make sure. Pretty good, 2.001 kilometers. We're good to go. And so that's the program in a nutshell. Great for mosaicing uh, files, great for producing MB-Tiles files for mobile devices and so on. And like all my other labs, it's absolutely free.